Hi folks, I have decided the product for my in this segment, which I have took will be very beneficial in case of machine learning is the static transition logic using AI and ML. So in this case, right now the problem statement is the static logic leads to the higher transaction failures. That is due to some of the payment gateways are not serviceable during specific time of the day, and those leads to higher transaction failures, increased operational cost. Means every payment gateway might have certain discount for certain type of a card transaction based upon the mode of the transaction, and higher transaction failures lead to the poor customer experience, leading to higher refunds and less order conversion rates, and that causes further revenue leakage for the clients. So in this, first key questions that we asked is there really a problem? Because millions of transactions are getting processed, but we are leaving money on the table due to concurrent single payment provider depending upon their availability. We would use a rule-based segregation model based upon the destination of the payment, origination of the payment, IP, success rates, downtime, mode of payment, and the payment provider. So in this case, the payment provider wants to get the maximize their profits and the discount rates and the MDR. So in this, we have just taken a normal crisp DM process about the business understanding how the transactions usually work and what are the usual transaction, understanding the transaction level data to choose the best possible method of depending on the offers available and the availability of the engine and the transaction completion percentage. So the general basic data preparation is there, so that the no missing values are there. Then the modeling the data and evaluation of the output will be the variable to define which is it will be the classification of the output to determine what is the best possible method of the transaction route that can be chosen, maybe the best possible gateway in this case. And then the further on deployment, we will discuss it on later. So in this case, the target users are merchants to for the transaction completion and the users who want to complete the transaction. And we have already discussed why it matters and what is the current status of the solution. So the target metrics in this case will be the higher transaction complete percentage and the profits from the again from the transaction to be increased by at least 10%. So gathering the previous data and the live data of the transactions are very critical thing, and the modeling of this data will be done on the previous transaction data and the offers available on during that duration to predict what was the best possible route during that transaction. So we will create further on more features such as offers available, discount percentage, offer validity, and of other offer details depending upon what offer details such as card payment method proposed, UPI proposed, or RuPay cards, Visa, MasterCard, Amex. Depending on all these details, we will create further new features upon that and label the data accordingly. We must ensure that there is no missing data found and no missing column entry so that the feature modeling is done perfectly on that. And outliers we are expliciting for the time being to get the real-time bottleneck of the data. For the data preparation, what we have decided is splitting the data set into 70-30 ratio, with the 70 is being the training data set and the 30% is the test data set. And just to repeat this exercise and make more data accessible for the model, we can use a k-fold cross validation method for at least 10 times to 15 times so that all the data is exclusively used, but we need to reduce this, we cannot increase this number to the higher extent so that the model may not overfit. And then the model selection, in this case the output must be a classification model, and so we need to choose a logistic regression can be one of those models where we need to classify the transaction and find what is the most optimal route to complete the transaction with maximum profits. So evaluating the model is optimizing the success and predicting the best possible route depending on the profits gained from the transaction, and the profits can be determined by the linear regression to predict the actual profit from each transaction, and leading to the cumulative profit determination and estimation of the correct profits. So in this case, what the machine learning system design we can choose is the cloud-based learning to be used, so that all the model scoring and the feature prediction can be done on the cloud level, and centrally stored variables and centrally stored modeling could be done. And the offline learning method we have chosen is because in order to train the data set from next time and collectively pulling more data set and revisiting those pipelines is a very essential process. And offline learning data set we have chosen because continuously improving the data set will have much more cost, and gathering the data set in the bulk level and injecting them and training them will be of a slightly lower cost. And in this case we have a real-time prediction because we need to route and optimize each transaction coming onto the workflow to optimize this. So solution what we have taken is a machine learning based routing system to predict optimal payment route for the transaction, minimum latency, cost, failure and probability to complete the transaction, continuously adapt to work and issuer and acquire conditions. So for example, let's say we can say the card based payment, we can go ahead with the geography. For example, all the UK based payments are over 100 euro can be gone with Edigen, and under 100 euro can go with Stripe. And if it is, let's say, local payments in India based to India, where it requires a transaction to be completed, we can choose with the NPCI based UPI method. And so let's go back to some highlighting what can be the potential risk in this model. The potential risk in this model could be uh, gaps in the training and serving queue, because there will be multiple number of vacant fields in this model that can lead to the skewness in the training data set, but lack of predictability in the test in the output data set, which is on the real time basis. And in this case, latency is the biggest threat because slight delay in the output can cause the transaction failures and increase the number of transaction failures, leading to the decrease in the overall business quality metrics to be shaken up. Thank you and have a nice day.